Hello again, students. This is going to be a quick review of the review for test one, which you can find in Pearson. Okay, so I decided to make this video for those students who haven't taken the test yet. Okay, and who need to do that ASAP. Okay, because it is due tomorrow. Well, yeah, since this is today Saturday, and the test is due tomorrow at 11 p.m. And yeah, I remember I said I wasn't gonna assign any due dates, but things changed, and I wasn't able to proctor the tests like I wanted to. You're not required to be proctor, so since this is an online class, so that's the reason things changed. And so I got that on writing. If you want to look at that, it's gonna be on their policy, course policy PDF in Moodle. And if you want to look at that, read. You're supposed to anyway. And that makes it official. Okay. So this review is for those students who haven't finished the tests, who haven't taken the test. If you've already taken the test, don't worry about it, because this would seem redundant to you. You may want to stay if you want to. You may want to learn how I do, things, how I work out problems. You may learn a thing or two differently. You may want to review. Okay, that's fine. You can stay. But but you don't have to. You don't have to. Okay. And let's see what else. I believe that's all I had to say before I started the test. If I think of anything, oh yeah, well, all those ums and ams you keep hearing, it's because see, I did it again. It's because I'm talking to my laptop here. So I noticed. Yeah, I've noticed that in previous videos. Because it's not the same as talking to an audience. I'm not having a conversation here. I'm not having a back and forth with you. It's just my computer and I. So yeah, there I did it again. All those ums and ams are just to filling, gaps. That's what I've noticed. I shouldn't. I will work on that and see if I can get better at not making the much. Well, I'm still gonna have gaps in there, but I'm not trying not to say so many ums and ams. Okay. Anyway, I just wanted to make you aware of that. And that is those are all the announcements I have. So let's go ahead and get started. This is gonna be quick, like I said. For an in-depth description or of these problems, always make sure you go back to your multimedia library and which you can find on left side. My library is not. I mean, my yeah, it is. It wasn't there. Multimedia library. Just click on the left. Yeah, I've already shown you that in the first video. So just click on multimedia library. Go to your textbook and videos if you want, and work off of that. Okay. And if you can't get the answer, just for whatever reason, just let me know, and I should be able to help. Okay. So let's go ahead and get started. The first thing I have to say about the test, even though this is not the test, this is just a review. You should read the question. You should read the questions. See, like right here, this is the question. and you should read that, and it should tell you everything you need to know to answer the problem. That's one thing that you need to be aware of, because I see students making mistake after mistake. I mean, like little mistakes, and I will show you what I mean when I work out these problems. But I see students make, I mean, silly mistakes because they don't read the question. See, just read the question. This should look familiar. Should look familiar because it's already in the ebook. Remember, because this is Pearson, therefore they were everything the same. Well, not everything, but it's gonna be similar, very similar. So, for example, the questions more than likely they're gonna word that the same. So, if you can practice on your assignments and try to memorize, the ways they ask the questions, actually going into your dictionary, and see what some of those questions means. I mean, some of those terms mean, because you may not be familiar with some of those. So go. I would recommend going there and look for the definitions of some of these terms. Okay, and you should be able to answer every question. Once you work out problems in your assignment, you should be able to answer most of these questions on the review and on the real test. Okay, because they should look familiar. Okay, so let me first start with this one. I was gonna go to the to my document camera, which is this. So it's gonna look like this. Whenever I work out problems, I'm gonna do it here. Okay, so that's what I'm gonna be doing. I'm gonna be transitioning back and forth. That's all I'm gonna be doing. Okay, and so right now I'm just reading the question here. So the question says to express the repeated multiplication in exponential and in words. Exponential notation and in words. Okay, so if you don't know what exponential notation means, just go ahead and look it up in your ebook. Okay, you're gonna see that in your assignments. So read through your ebook through to the correct chapter and section, and you should be able to know what these terms mean. Okay, so in this case I have two different questions, so let's go ahead and answer the first one. And like I told you before, this whenever you read the question, that's going to tell you exactly what to do. Okay, in this case we need to express the repeated multiplication in exponential notation. Why are they making that specific? Because we have different kinds of notation. We have fractional notation, we have decimal notation, those you're familiar with, and we also have other kinds of notation that we're not going to work with in this class, but there are different kinds of notation. So you have to be familiar with exponential notation. Whenever somebody tells you to write exponential notation, your mind should go to something that looks like something to the x power, right? That's gonna be your power there. So exponential notations should look something like this. Okay, your mind should make a mental picture of something like that. Okay, so it's very, very specific. It's not. Well, let me take you back here really quick. It's not. You are not supposed to multiply 5 times 5, because if you look at this problem here, just by looking at it, you will be thinking that, oh, you're supposed to multiply 5 times 5. Okay, well, 25. But the answer will be wrong. Okay, and if you read here in the words in blue, type your answer using exponential notation. Okay, this I recommend you read, even though most of the time you're gonna be skipping the definitions, well, the instructions here in blue. This is not part of the question, but it's gonna guide you to how to enter in the answer. Okay, so I would recommend you read that every time. And in this case, it tells us to use exponential notation. So the answer is not 25, as you would think just by looking at this, right? The answer is, and I will take you back to here. And I don't know why it does that. I don't know why it does that. It just blows the whole thing. Let me see if I can fix that really quick. All right, I think that looks better. So let's skip it there, see if that works. All right, so it was 5 times 5. We need to write in exponential notation. Like I told you, you might should go to something like this, right? Well, that power of 5, it always tells you how many times you write down the base. You write it twice, and then just multiply, because exponential notation means multiplication, right? So this is this in exponential notation. Okay, so the answer should be, let me go back. Oops, let me go back really quick. So the answer should be 5, 2, and make sure you use this palette down here, because it has some buttons that your laptop doesn't have. Okay, yeah, your computer. Some extra buttons here. In this case, we need the exponential notation button there, and we need to write a 2 in there, and that should be the answer. You could either click on check answer here, or you click enter. I click enter most of the time. In that way, I don't have to use my mouse. Click OK. We are done with the first part there. Now we have a second part. Remember, sometimes you have two parts. I've seen students who miss the second part because they don't know that there are some questions like this. Okay. In this case, you have two parts. We already done one. Now we need to work on the second one. In this case, they tell us to write it in words. Okay. We know that this is the base. That's 5 to the exponent 2. Okay, so 5, either 5 squared or 5 to the second exponent. And so let's see, 5 added 2 times. No, if you add 2 times, you're not using exponents. 5 to the second power, there it is, 5 to the second power. Let's see if any of these two work. 2 to the 5th power, no, that would be 2, meaning the base. The base is not 2, the base is 5, so no, that's not going to work. 5 multiplied by 2. 5 multiplied by 2, that looks something like this, right? So don't be fooled though, because they're asking us for exponential notation. Okay, so this wouldn't be the answer, even though this describes this expression to the left. That is not the answer. Okay, so the answer should be A. Click enter or check answer. Whoops. I clicked on the wrong one over there. It's 5 to the second power, and we already already told you that before, so that should have been the answer. I just messed that up, but that's okay. In this case, they're still asking about same similar question. In this case, the base should be the number that you're writing, right? In this case, 8. And then for the exponents, that's how many times you write it. Okay, so 1, 2, 3, 4, 5, just 5. That should be your exponent. Click enter. Click enter again, and you're done. Okay, and then for to go to the next question, just either click up here on the arrow or the arrow down here. Next question. Oh, we have a second part there. So let me go ahead and go back over here. And again, this is a to the fifth, a to the fifth, a to the fifth power is right here. So that should be the answer. Click enter and enter again. And we're done with that question. Okay. And by the way, if you want to skip questions, just click on the next button, and that should skip that question. Okay. And then if you click on the drop-down menu, it should show over here. See how it we get a 0 over here, and that should tell you which question you have missed, or or which questions you have partial credit for, and therefore you need to go back and finish those. So it's good to look at the drop-down menu, because sometimes you miss questions and you didn't even know it, and this tells you exactly which questions you missed or you have done partial credit. And so use it, and it should keep you from making from skipping questions. Okay, so in this case we need to find the value of the expression 10 to the second power. Okay, in this case this is a different question. They're asking us to find the value of this of the expression. Okay, so in this case, and remember this word, I would say memorize it, because we're going to use this word a lot. Expression is make sure that you don't confuse it with equation, even though they sort of rhyme. An expression is never an equation. Okay, once you get an equation, there's going to be an equal sign in there. Therefore, if you call an equation an expression, you would be wrong, because that would make it an equation. So an expression is values like this, with or without any operations, meaning addition, subtraction, division, or whatever. In this case, you have an expression here which doesn't have any addition or subtraction, but you do have an exponent here. Okay, so let's go ahead and find the value of this expression. What does that mean? To me, the easiest way to solve this kind of problem, is to write the base this many times, because this one will tell you how many times you write the base. So let me take you back here and tell you how I would do that. So we have a 10 to the second power. I would write the base twice, because the exponent tells you how many times you write, and just multiply it. Okay, I know that 10 times 10 is 100, so I don't even have to do it by hand, because I already know that by memory. So in this case, the answer is 100. Okay, click enter or check answer, click next question or click enter, and that should take you to the next question. Okay, and then here, evaluate the exponential expression. Okay, there's another word that you need to memorize. Okay, evaluate the exponential expression. Okay, evaluate, you can think about it as it's close to simplifying, but the way I like to think about it is work out the problem. Just work it out. It doesn't matter. It doesn't make a difference if you have an equation, or, an expression, any kind of expression. Just go ahead and work it out as much as you can, because you might be, it may not simplify all the way to one single value, but just do whatever you can to evaluate. Okay. So in this case, like I told you, evaluate, to me, it means work it out. You can use different words, whatever other words you want to use to memorize this word. Okay, so differentiate that from solving, from the word solving, from the word simplifying. Okay, because those are three different words, and they are used different scenarios. For example, the word solve means solving for x. If you had an equation here, you would solve for x if you had that word in there. But in this case, they're telling you to evaluate, so therefore you're not solving for any missing variables, okay? And we're gonna get to that very soon, actually. I think we're gonna get to that some variables in this review in a few minutes. But let's go ahead and solve this, evaluate this exponential expression. Okay, so we know that we have an exponential expression, and this is the way I would do it. Exponential expression is for the fifth, I believe it was. And again, I told you to write down how many times. Let me go back and see if that's the right expression. Yeah, 4 to the fifth power. And then multiply that. Yeah, multiply the whole thing. Multiply. Multiply from left to right, just so you can get used to it, even though you can multiply from the right to the left here. But the order of operation calls for performing operations from left to right, so get used to it. So I would start from left to right. So here I need to multiply 4 times 4, that's 16, right? I'm done with that. That's what I would do, okay? I'm done with that. I don't have to worry about that. Now I need to multiply 16 times 4. Okay, so I'm doing that by hand. And if you haven't practiced your multiplication tables, make sure you do that, because that's gonna speed up things significantly, okay? 6 times 4 is 24, write 4 and carry the 2. 4 times 1 is 4, plus 2 is 6. So now I have 64, if I'm doing everything correctly. I'm just showing you how I would do it, okay? And I'm not going to work out all the problems, but I'm just showing you how I would do it. And then multiply 64. And by the way, see how I'm writing my work to the right of the problem and not close to the problem? Well, in this case, I'm writing it close to the problem, but I would that's because I'm running out of screen here. But I would, if I was working out a problem in the test, I would do it like way over here to the right, and that way you don't get confused here with your work and the extra work that you're doing for the actual problem. Okay. So here I need to multiply 4 times 4. That is 16. 6 carry the 1. 4 times 6 is 24. Plus 1 is 25. Okay, so write down 2, 5, 6. Cross out the factors you have already used. And now I have I need to multiply 256 times 4 on the way over here. 4 times 6 is 24. 4 times 5 is 20. 20 plus 2 is 22. Carry the 2. 4 times 2 is 8, plus 2 is 10. All right, so the answer should be 1024. And I tell you what, let me go back over here and show you that this is problem 5. See up here? Problem 5 out of 72. So that's problem 5. So what I need you to do, if you want to, for the test, for the real test, make sure you write the number problem to the left, and put in a box or circle if you wish, whatever works for you, as long as you separate it from the problem, right? In that way, whenever I check your problems, because I'm gonna be checking your work. If you want to turn it in, I'm gonna be checking your work and giving you extra points. Okay, giving you extra points for that. If I see that you got what we're trying to teach you, okay. And this is the way I would like you to do it. Okay, write the number problem to the left, and then do your work to the right. Write the next number problem to the bottom there. Perform your work underneath, and keep on doing that. Once you are done with the test, scan your papers and email them to me if you want extra credits. And I'm telling you, if you do, you're gonna more than likely you're gonna get some extra credits. Yeah, I'm good with that. I'm very good at giving extra points, because sometimes the computer doesn't it if you miss just a little, a little sign or one digit, the computer's gonna count it wrong, and it's not gonna give you credit at all. But if I go in there and look at your work and see that you miss only one single thing out of a lot of things that we were trying to teach you, I'm gonna give you I could give you 1/4 of a point, half a point, 3/4 of a point, and that builds up. That builds up real quick, especially if you have like 60 questions on tests. So imagine if I give you half a point for 10 questions. That's almost 5 points out of the whole 5 extra points added to your grade, to your original grade. Okay, so if you want to do that, go ahead and do it. If you don't, that's fine by me, but I'm telling you, most students do, and they get extra credits. I've seen students get whole letter grades of extra credits. If you don't believe me, well, you should. Anyway, I just wanted to bring that to your attention, because I already told you that on a previous email. If you want to go in there and look at that email and see the instructions, read the instructions there. I told you that more thoroughly there, and so just go in there and see exactly what I mean. Okay. Anyway, this is problem 6, and now we need to evaluate again. Just work it out. Exponential expression. Why is it an exponential expression? Because of the power 2. Okay, that makes an exponential expression. Even though this 6 doesn't have a power up there, it does have one, but it's just one, just a 1. Okay. So let's go ahead and work that one out. How would I work that one out? I don't know why students mess this one up. They shouldn't, because I think it's because this 6 doesn't have a power up here. And that's what messes them up. I don't know why. Well, what's the other value? 6 times 4 squared. Remember that you need to evaluate, okay? You don't need to write the answer in exponential notation. No, not this time. That's why I keep telling you to read the question thoroughly, and that should guide you. It should guide you to what you have to do on the problem. Okay, in this case, I'm gonna go ahead and rewrite everything except for this time. I'm gonna write 4 times 4 instead of 4 to the 4th power. Multiply from left to right. 6 times 4 is 24. Cross those two out. 24 times 4 is 16. Carry the 1. 4 times 2 is 8. Plus 1 is 9. 96. So the answer should be 96. Okay, 96. That should be the answer. Oh, and by the way, if you could circle the answer, that would be awesome too. So for example, up here the answer was 256, I believe. No, 1024. Circle the answer. Up here it was 100. Circle the answer. Up here was 5 times 5, I think. Okay, so that's what I need you to do. This will help me when I'm grading your work, because it tells me the exactly where to look, because I know that this is not included in here because of this, and I know that this is the answer and not any of this. See what I'm saying? So that helps a lot. Okay, also let's go back over here, and then just type in your answer in there and continue with the next problem. Okay, I'm just gonna go ahead and click on the drop down menu so that you can see now what it looks like when you skip a question. See, now if we skip a question, you can click on it and that'll take you back to it. Okay, and now you can answer the question. Okay, explicit interpreting multiplication, exponential notation. That's 4 to the second power and 7 times 7. Well, let's go ahead and type it in really quick and use the exponent button here. How many times did you write it? Twice, so that goes there. And here, I don't know why students don't get that this is a multiplication, that these two are being multiplied times these two, and that those two are written separately, and that multiplication sign is here, I believe. Yeah, multiply times 7, that's the base, and then click on the exponent button, and you wrote it down. They wrote it down 3 times, so 3 times, so the exponent is 3. Click enter. That should be good. Yeah, and then just answer the rest of the question. I'm just gonna skip the rest of that because you should already know how to do that. So let's go ahead and go back to 6. Yeah, skip that for now. And no, we already worked on that one. Let's go to the next one. Okay, so here's another good problem that tests you on the order operation. Okay, let me go ahead and just write down the problem really quick, and I'm not going to work out all of these problems because I just want to give you some hints on how to go about working out these kind of problems when you're using the order operation. And let me just write it down really quick, and that way I don't have to look back and forth here once I go into my document camera. Okay, so 7 times parentheses 10 minus 9 to the 5th power. Okay. All right, so let's go to my document camera real quick. And this is problem 7, I believe it was. It doesn't make a difference. I just want to show you how I want you to do the work. Okay, I want you to write it down. Problem number right there. This is the problem. Go ahead and write it down. And I would suggest you write down these kinds of problems. Don't try to skip any steps right away unless you're really good at it, or else you're gonna start making mistakes. And this is the way I would like you to start these problems. Go and just you could write your order operation close by if you want, or at the top of the page. It doesn't make a difference to me as long as you have it there. In that way, you don't have to think about it. That way, you don't have to think about it. And make mistakes. Okay, so in this case, this means parentheses, exponents, like I told you, something that looks like this. You might want to do that. Multiplication, do that. Division, do this. Whatever helps. It's up to you, really. That's good. That is good. You could even write the names, parentheses. Oops. It's exponents, multiplication, whatever helps you, whatever guides you better. Yeah, multiplication and so on. Okay, and then from here, remember that, and this is where students make most mistakes. They whenever you have a multiplication or division, whichever comes first, perform the operation. Can you remember that? And then addition and subtraction, whichever comes first, perform the operation first. Okay, that means multiplication, that multiplication, and in this case we have subtraction here. Perform those operations first. Okay, these two. So in this case, whichever comes first, from left to right. Okay, from left to right, perform the operation first. Okay. In this case, you can swap these two, or you can swap these two, but you cannot swap from this box to this box, okay? Or from this box to this box, okay? Cannot do that, okay? Or else the order of operation is going to be wrong. So make sure that you remember this step here. You can swap these two or these two, but not these two, okay? And the order of operation goes from left to right. Whatever comes first, whatever operation comes first, you perform that when you're talking about multiplication, division, and addition and subtraction. All right, so let's go ahead and start with parentheses. Okay, so I have a parenthesis here and a parenthesis here. So let's go ahead and start working on this left one. And this is the way I would do it, okay? This is the way I would do it, and I would suggest you follow me at least the first few months. Well, in this case, it's going to be weeks. And from here, I'm going to work inside the parentheses, okay? 8 minus 7. I only have one operation inside the parentheses, so 8 minus 7 is 1. And then rewrite everything else. And I know you think you're going to be saving time by skipping steps, but the first few times, try not to skip any steps. Just rewrite everything else. Perform one operation, go back to the left, and look at this problem from left to right again. Okay? Yeah, we said to start working from left to right. Okay, so again, the order operation calls for parentheses. Let's go from left to right. I already worked on that one. I don't have to worry about it anymore. I do have one over here, so I need to work on that one next. I rewrite everything else and work inside this parenthesis. 10 minus 9 is 1 to the 5th power. Okay, rewrite everything else. Okay, I don't have any more parentheses, so I'm going to go to my exponents. And again, start working from left to right. See what I'm doing? Every time I perform one operation, I go back to the left, okay? Go back to the left and work my way to the right, okay? Every time you perform an operation, go back to the left and work your way to the right, all right? In this case, we don't have any more parentheses. We do have exponents, so there's one exponent there. So that's what I'm going to do. I'm going to work on that exponent first, the one on the left. As 1 to the 3rd power, that's just 1. Rewrite everything else. I'm just going to rewrite everything else. And I suggest you do the same thing too. All right. So I'm going back to the exponents because I do have one over here. And I need to look at this from left to right again. So I don't have anything here, any exponents or parentheses, except for all the way to the right, okay? So I rewrite everything else. 7 times 1 to the 5th power is just 1 again, okay? And, oops, let me go back up here. And now I don't have any more exponents. I need to go back to the left and look for any multiplications, okay? Oh, well, right here, the very first operation is a multiplication. 9 times 1 is 9. Rewrite everything else. See, because if you rewrite everything else, you can see exactly what operations you're working with. Okay, and again, I'm gonna go to the left, start from the left to right, and see if there are any more multiplications. See, because even though I already worked on multiplication, I still need to go back to the left and see if I have any more multiplications, and I do. It's right there. 9 minus 7 times 1 is just 7. 9 minus 7. Oh, well, let's go back over here to the order of operations. Division, I don't have any more divisions. Addition, I don't have any addition. Subtraction, yeah, that's what I need to do, because I only have one operation left. 9 minus 7 is 2. So the answer should be 2. Okay. All right. Let's see if we are right. If we did everything correctly, the answer should be 2. If not, then we did something wrong. But yeah, we did. Click on next. And we should be going to the next problem. Okay, so this is the only other problem I'm going to work on to show you how I work order operations, and because I don't want to be here all night, so I'm just going to go ahead and start by writing down the problem, number problem there, and then the problem itself. That's 4 times, that's a bracket, 2 to the second power plus 8. And I would suggest you do the same thing, write the whole problem. Write the whole problem, start there. Don't try to work it off of the screen. No. And write it down so that you can have it right in front of you. See? And that's going to keep you from making mistakes. And I know that works because I've done it myself, and I've taught it, and it works. It just works. Okay. All right. So now I'm here again. If I were you, I would write the order operation up here somewhere and work off of that instead of having to rely on my memory, be thinking about that in my brain, and then working out the whole thing. That's gonna that may mess up your work. Okay, that may mess up your work. It may or it may not, but in my experience, you make more mistakes if you don't write this down. Okay. All right, so let's go ahead and start working with parentheses. Okay. Let me there, and I don't know why that is there. All right, parentheses. All right, that's better, I think. Well, no, there. Parentheses, and in this case, I have a parenthesis inside here. This, even though this is a bracket, is also think about it as being a parenthesis. Okay, because what the parentheses do? They just group. They group. Okay, they're grouping. See, this parenthesis is grouping this two values. This bracket parenthesis are grouping all of this. Okay, that's all they do. Okay, sometimes they group, sometimes they multiply. So be aware of that. In this case, they're grouping. Okay, and in this case, you have a parenthesis inside a parenthesis. And the way you work this out is by starting inside the innermost parenthesis. Okay, see, this is the innermost parenthesis, so that's where you start. Okay, and that's a good practice. That's good practice, and it's going to help you out whenever you're working those long algebra problems, if you ever have to. Anyway, parentheses. Rewrite everything else, and it doesn't take long to rewrite everything else, guys. It really doesn't. You might be thinking that you're saving time, but it's just a few milliseconds or a few seconds, but not much at all. A minus 5 is 3, and I just left that in parentheses for now, and then rewrite everything else. and go back up here. Well, I'm still working inside parentheses. Okay. Well, in this case, I can see that I have several operations. Well, in this case, since parentheses are grouping, think about it as being a different problem. So you go back up here and start from left again. Start from left with parentheses, exponents. Yeah, we do have an exponent here. So I'm rewriting everything else. And performing this operation here, 2 times 2. That's 4. All right, I almost skipped it. Yeah, that's okay. Rewrite everything else. I'm just going to leave this in parentheses for now. That's okay, not a problem. Just to show you that this parenthesis is this parenthesis, okay? But you don't have to. Once you get good at it, you're going to start skipping steps, and that's okay. All right. Again, we're still working inside parentheses. Go back to the left. Do you have any more parentheses? No. Any exponents? No. Multiplication? Yes, you have one there. So rewrite everything else. 4 plus 3 times 4. Yeah, this is 3 times 4. 12. So that parenthesis goes away, and then rewrite everything else. Write everything else. And if and again, see inside when I was working inside the parentheses, I work from left to right. Okay, I went from left to right, and I still need to do it here, even though I only have one operation there. And again, same thing with this here, with the other operation. Go back to your left and start working from the right. Every time you perform an operation, start working from left to right. Every time you perform an operation, start working from left to right. Okay, so we went from parentheses. Yeah, we do have parentheses there. And then an exponents. No, we don't have any more exponents inside the parentheses. Multiplication, no. Division, no. Addition, yes. So we need to work on that. So 4 times brackets, 4 times 12. And again, you could work out this problem. If you can do it in your head, work it over here, on the left, on the right, away from your work. It helps. It really helps keep everything tidy. Yes, and from making mistakes too. 4 times 2 is 8. 4 times 1 is 4. So write 48 inside the brackets. Okay, rewrite everything else. All right. And then again, go back to the left parentheses. Well, we do have a parenthesis there, but we already perform all the operations. Any exponents? No. Multiplication from left to right? Oh yeah, we do. Again, go ahead and work out that multiplication, which is 4 times 48. Away from your work. 4 times 8. If you can do it in your head. If you can, well, just go ahead and write out your answer. 4 times 8 is 32. Write 2 and carry the 3. 4 times 4 is 16. 16 plus 3 is 19. And write that down over here. And rewrite everything else. And the parenthesis goes away, or bracket, times 0.2. And I said parentheses because brackets the same thing as parentheses, like I told you before. Okay, and I would use a parenthesis here instead of a bracket if I wanted to, because it's the same thing. And in fact, I would rather you use parentheses, because if you go into an algebra class, you're going to use a graphing calculator, and graphing calculators use parentheses a lot. I mean, that's the only thing they use. They don't use any brackets. And I haven't made any mistakes, I don't think, any noticeable mistakes writing parentheses inside a graphing calculator. It's very simple to see, very simple to use. Okay. Anyway, where was I? Okay, so I'm down here, and I need to go back up here and look at my order operation. Parentheses, exponents, no. Exponents, multiplication, yes. From left to right, I can see that I need to multiply 10 times 2. So I rewrite everything else and multiply 10 times 2. That's 20. And now I'm here. Okay. Again, go back to your left over here. Are there any parentheses? No. Exponents? No. Multiplication? No. Division? No. Addition? No. Subtraction? Yes. And I'm just gonna go ahead and perform a subtraction here, just in case you guys can't remember what the rules are for subtracting. This is gonna be a quick lesson here. And in this case, whenever you subtract, the place values matter, okay? Because think about this 192 as being to the left of the decimal, okay? So place value does matter whenever you add or subtract, okay? Okay, so in this case, we need to start from right to left, okay? Because we need to work with ones first, then tens, and hundreds, then and so on. And that's why we need to work from left to right, not from right to left. So have a subtraction here. Okay, 2 minus 0 is just 2. 9 minus 2 is 7. 1 minus 0 is just 1. So the answer is 172. That should be my answer. Circle it. In this way, this is what you would turn into me. This makes it easier on me when I'm trying to look at the screen, because I can see your work on Pearson, and I can also see you if you email it to me. If you mail in your work to me, I can also see it in front of me, and in that way I can see the problem number and pair it up with your work in Pearson, which will look something like this. See, will look something like that, and that's how I can. That's why I would know that the work on problem 8. The work on problem 8 is referring to this problem. Okay, that's how I guide myself. Okay. All right, so we're done with that problem. What we said the answer was 172. See if that's correct. Okay, so if it's not correct, then if it's not correct, if you did something incorrect, then you're gonna have to go back and look at your work. Okay, you're gonna have to go back and look at your work and see what you did wrong. Okay, and in this case, I'm not gonna go back because I went real fast here. I just wanted to show you the process that we do, and this is exactly how I want you to do it. Okay, you need to be more careful when multiplying and subtracting and adding and all the stuff. Okay, and that should do it for order operations. Okay, and now I'm gonna go back over here and skip problems here, because I know that yeah, skip that. Yeah, I know that this problem is also an order operation problem. And okay, so that's a different problem. So let me go back over here real quick, just to point out that this, even though it is a fraction, it is also a division, because this is a division line. Okay, and it is also grouping the numerator and the denominator, okay, separately. So think about the numerator as having parentheses, okay? The numerator is having parentheses, and the denominator is also having parentheses, okay? Because that's what parentheses do. They group, right? And since this line is separating this top part and from this bottom part, it's grouping this part up here and this part down here, okay? So whenever you look at your order of operation, PEMDAS, think about this as having parentheses, okay? So that's where you start. That's where you will start. And I believe that's the only other thing I had to add there. And yeah, and just think about the order operation. Be careful, and you should be okay. All right. All right. So let's go to the next one. Evaluate the following expressions for z equals 2. And this is another one of those problems that students struggle with. I don't know why. And yeah, of course, one of the reasons is because they haven't done much homework, right? They haven't practiced much. So let me just write it down real quick. Okay, no, I don't think I even have to write it down. Well, hold on. Okay, so we need to evaluate. Remember what that means? It means just work it out. Well, if you only had this information here, you wouldn't know how to work it out, right? You would think that you were trying to solve for z, right? And that I believe that's where students make the mistakes. That whenever they see a variable, they think you're supposed to solve. However, that's not necessarily true, because you need to read instructions, of course. And like I've been telling you. So evaluate the following expression, and there's that word again, expression. Okay, so this is what an expression looks like. This is not an equation. And then evaluate the expression for z equals 2. Okay, for this z equals 2. So it's not telling you to solve. See, it's telling you to evaluate. Therefore, your brain should have gone like, no, that z shouldn't be there, because I'm not solving. Now, if he was telling you to simplify, then yeah, you could have a variable here without a problem. Yeah, but in this case, it's telling you to evaluate. Therefore, your brain should have gone like, what's the value of z, right? Well, it's telling you up here, value of z is 2. So you substitute 2 in there for z and evaluate. See, there you go. That's a 2. 11 minus 2. Oh, that's an equal sign. 11 minus 2 is 9. So the answer should be 9. Okay. So don't think that you're trying to solve for z. Okay. If you see a variable, don't immediately think that you're supposed to solve. Okay. And like I keep telling you, the words evaluate, simplify, evaluate, simplify, and solve are 3 different things. Okay, they're not, even though it may look interchangeable, they are not necessarily. No. So be thinking about these 3 words and their differences. Okay. All right, let's go back over here to the next problem. Evaluate. Again, there's that word, evaluate again. And in this case, you have a comma right there. Okay, so they are asking it a different way. Even though you're still evaluating, they wrote it down differently this time. In this case, there's a comma there. Well, what do you need to think about when you see a comma in mathematics? Well, in mathematics, the only commas we use is when we write like, I don't know, thousands, like 1,304. We write a comma in there. Sometimes, most of the time we skip them, right? If they were typing it in, then in the book, they would probably show it. but most of the time we skip it. In this case, this comma is not referring to thousands. That's like a given. It's not. It's just not. In this case, this comma is separating this these thoughts, whatever that is, from this here. Okay, and you need to be aware of that. So what is it telling us? Well, to evaluate, and you need to evaluate what? Well, you need to evaluate this expression for g equals 9. Okay, so don't let all of this throw you off. These are two thoughts. This is the expression that you are evaluating for g equals 9. For this g equals 9. Okay, so just substitute the 9 in there for the letter g, and well, for the variable g, and then just divide 54. 54 divided by 9. That should be a 6. So the answer should be 6. Type in 6, and you're done. Okay, because remember, we're not solving for g. It doesn't tell us to solve for g. It tells us to evaluate. Okay. All right. Let's move on to the next one. Evaluate the following expression. Again, evaluate. Whenever you see this word, just think about you have to work out a problem, basic development problem, right? Well, in this case, they're telling us to use 3 for x. So why are they doing that, by the way? Well, because they are making you familiar with the fact that you can write numbers, letters to express numbers. Okay, those two can mean the same thing. Okay, a letter and a number can mean the same thing. In this case, the letter x means 3. Okay, in this problem, and so substitute x here in this expression. 3 for x, substituting here. So in this case, this group up here, the numerator, is telling us to multiply 5 times 3. 5 times 3 is 15. 15 plus 8, plus 3 is 18. I was getting ahead of myself there. 15 plus 3 is 18. And then substitute 3 in here for the x and multiply through 2 times 3. And that's 6. 18 divided by 6 is 3. So the answer should be 3. Just type in 3 in there and you have evaluated. Okay. All right, let's move on. And let's see here. 3x finds, it says to find 3x plus y when x equals 4 and y equals 9. Okay, see how we're essentially doing the same thing. We're evaluating, right? But they are asking it a different way. Okay, and this is why assignments come in handy, because that's where you practice and that's where you get familiar with the wording of the questions. See, that's why we need to practice, before we do a test or even a review. Okay, so in this case, we need to substitute 4 for the letter x there. 3 times 4 is 12 plus y, which in this case is 9. So 12 plus 9, that's 21. So the answer is 21. Write it down and click enter. And that should be the answer, okay? All right, let's see what else. Again, we're just evaluating. That's why I'm not writing everything down, because these problems are similar. If I need to write anything down, I'll do it. That's not a problem, okay? Okay, so evaluate the given expression for. Okay, so they're telling us to evaluate. In this case, they gave us the two values here. And just substitute 8 for x here and 6 for y, and 6 for y here, and 8 for x here. Perform the operations, follow the order operations PEMDAS, and you should come up with one single value, okay? Not a variable, okay? Because just remember, you substitute all the variables in here, inside the expression. All right, let's move on. Write the following phrase as a variable expression. Okay, so this is a different kind of problem. Use x to represent a number. Okay, so in this case, we need to write the following phrase as a variable expression. Okay, so whenever they throw in the word right, you're thinking that you're gonna end up with something that looks like this, right? With words. Well, in this case, you won't, because it's telling you to write the following expression in variable expression. Okay, what does that mean? Variables. Well, variable expression means it's referring to variable. Okay, yeah, it's referring to the variables. So in other words, you're gonna end up with letters in there, and numbers, and of course operations. Okay, and remember this word again. Okay, here it is again. Expression. You're gonna use that word a lot. An expression is composed of variables, could be composed of variables and operations and numbers. Okay. All right. In this case, we need to translate this word phrase into, or sentence into a variable expression. Okay. So let's go ahead and read it. The sum of a number and 7. Okay, so what does the sum of a number and 7 look like? Well, I know I'm going to have a plus in there somewhere, right? Because it's a sum. A sum of sum means addition, right? So I know I'm going to have an addition sign in there. Sum of what? Well, a number. Okay, in this case, I'm going to write it as it is written here. It comes first, therefore I'm going to write it here. A number. What number? Well, it doesn't tell us what number. But in this case, in the instruction over here, it tells us to use an X. So I'm just gonna use the keyboard here to write an X there. Move to the right there. I used my arrow there, my arrow key in the in my laptop, and I moved to the left. That's how I move, either left or right or left. That seems to be more accurate and faster, I think. So use your arrow keys in your laptop. And then from here, I need to write a 7 to the right there. 7, because it's an sum. Yeah. So it's a sum of a number and 7. Okay. And then just click enter, and that should count it correctly. That should be the answer. Okay, again, write the following phrase as a variable expression. Okay, variable expression. Again, we're still working with variables. Expressions, and you should be familiar with that word already. So 17 subtracted from a number. 17 subtracted from a number. And remember, on the previous problem, we essentially wrote down word by word down here. In this case, watch what happens if I do that. 17 subtracted by 17. Oh no, well, in this case, in this case it's going to work. Okay, so 17. I know I don't have a subtraction there, so I'm just going to use the subtraction sign. And you could also use this button so here, okay, if you want, or you can use the ones on your keyboard. It's not a problem. Both of them work. 17 subtracted from. Oh no, that's not going to work. Subtracting from a number. But see what happens when I write it as it is written up here. It's sometimes it works with addition every single time, but not with subtraction. Watch. Let me show you what I mean. So let me go ahead and write the other number. I don't know what number. Just tell me a number, so I'm going to use X. I'm going to write X in there, and then I'm going to click on check answer, and it's going to tell me that I got it incorrect. Why did I get it incorrect? Well, because, and let's go over here and read this expression. This expression says 17 minus X, 17 minus a number. But that's not what this expression is saying, what this phrase is saying. So notice the difference. This expression here is 17 minus, or reads 17 minus x. But that's not what this is saying. This is saying 17 subtracted from a number. Therefore, this x needs to be on this side, and this 17 needs to be on the other side. So we need to swap those two. So I'm just going to go in there and use the arrows there and just delete everything and write the x first. X minus, and I'm just going to use this button here. 17, write 17 there. Click enter. And notice how the answer is correct now. That's because those 17 minus x is not the same thing as x minus 7. With addition, both ways will be correct. If you write a 17 first, or if you write last, with addition, it's always going to work. It's always gonna you're always going to get the right answer, but not with subtraction. Okay, so be careful. Be careful when you have one of these expressions that you're supposed to translate and you're subtracting. Okay, because the way they word it has a lot of significance. Okay, like we just saw. Okay, so make sure that doesn't trip you. Okay. All right. So again, we're still doing the same. 4 decreased by a number. 4 decreased by a number. And I do want to work out most of these problems because this is where students make a lot of mistakes. And I keep telling them you need to practice this, but they don't listen to me. Anyway, 4 decreased by a number. See, there it is again. Remember that whenever you're subtracting, you need to be careful. You need to be careful because if you write a number at the beginning or at the end, it's not gonna mean the same thing. Okay. So in this case, we subtract 4 decreased by a number. 4 decreased by a number 4. Okay, so let me write 4, and I need to decrease it by a number. It means I'm gonna have to subtract that number from 4. Okay, so now I have 4 minus x, which is the same thing as 4 decreased by a number. All right, let's see if that's correct. Yeah, that's correct. So in this case, it was correct. Writing the 4 first, just like that phrase right there, and then the x. In this case, it worked, but not in the previous one. Okay, so be careful with that whenever you're subtracting. Again, we have no decrease by problem, and this is the reason I have them here, because students make a lot of mistakes here with subtractions. 18 times a number decreased by 5. 18 times a number. And you can start typing in, values here and then read them out loud to you once they're over here and see if they make sense. Okay, and that's one way of doing it. 18 times a number. Well, I don't know what number, so I'm just gonna write x in there for it. And most of the time you're gonna write x. They're gonna use x for a missing value, unless you are missing 2 values, more than 1, right? But most of the time you're going to use x. Okay, so 18 times a number decreased by 5. Okay, so I know that I need to subtract 5 from it because this expression is being decreased by 5. That's what it means. Okay, so 18x minus 5. Click enter. Good. Yeah, that was it. And then 1 less than the product of 3 and a number. 1 less than the product of 3 and a number. Okay, 1 less than the product. Well, let me go ahead and try to type in 1 first, and then minus the product of 3 and a number. A product means multiplication. That's another word you need to remember, okay? Product refers to multiplication, okay? Product refers to multiplication. You need to memorize that word. We're going to use it a lot in this class. The word product equals multiplication. What your brain should go into get a picture of a multiplication sign or something like that, okay? Something along those lines should be a good start. 3 times x times x. So what if I click enter? Well, it's going to tell me it's incorrect. Why? Well, let's go back and read it. Read it from down here, not up here. Now let's go backwards. Yeah, essentially we're going backwards, right? We're reading from here. 1 minus 3 times x. Well, that's not what this is telling us. This is telling us that we need to multiply 3 times a number, and then we need to take away from those numbers. Yeah, from that expression. So I'm just going to go ahead and include that 1 to the right instead. See now, this means this, okay? Because this less is not the same thing as minus, okay? That's where students make mistakes. Well, make a lot of mistakes. It essentially you are using a subtraction sign, but you're not. This less term doesn't mean the same thing as minus, okay? It doesn't transliterate into that, okay? So be careful with that. Click enter, and that was the right answer, okay? Let's see what else. 8 more than the quotient of a number and 6. 8 more than the quotient of. Well, let's see if by transliterating everything gives us the right answer. More means an addition, right? Yeah. A quotient of a number. Quotient, that's another word I need to memorize. Product and quotient. This word quotient refers to division, okay? Memorize it because you're going to see it a lot in this class, okay? Quotient of a number and 6. Quotient means fraction. In this case, they have extra information for us here. Use whole numbers or fractions for any numbers in the expression, okay? Whole numbers or fractions, okay? So we can use a fraction. Well, there's a fraction button over here. We use that. The cursor is already in the numerator there. And whenever you're working with quotients, whatever comes first, that's your numerator, okay? In this case, a number, so x. I'm just using my arrow keys and my right arrow key, and that took me to the bottom there. And now 6, just write 6 in there, and that should be okay. So like I said, is this correct? Well, let's see. It is correct. It counted correct because, like I told you before, even though this doesn't transliterate to, well, it does transliterate to that, it doesn't translate to it. See, those are two different things. Transliterate and translate. Those are two different things. It should translate to x over 6 plus 8. However, when you actually work out the problem, if you were to work it out, you will still get the same answer because you're adding. So for example, let me take you over here to my document camera over here, and there. That's fine. Okay, let me put it in the middle here, the center there. And let's go here. And what was I saying? So for example, 8 plus 2 equals 10, and 2 plus 8 equals, it's also 10. See what I'm saying? However, 8 minus 2 equals 6 is not the same thing as 2 minus 8. See, that's now you got a negative value, -6. So those are not two different values, two different way different values. Okay, they're not even close. I mean, not even close at all. All right, so make sure you remember this. Okay, whenever you're working with addition, you're gonna get away with transliterating your phrases. But whenever you work with subtraction, be careful. Okay, subtraction, less than, less, minus, phrases like that. Be careful. Okay. All right, let me take you back to Pearson over here. All right, click on next. And I know we're taking a long time, but that's because just in case you guys don't know how to do this, because I noticed that a lot of you did not work out the assignments. Okay, so maybe this is the first time you're looking at some of these examples, and so I need to make sure that I covered everything. Okay, so I'm gonna go over the whole thing. So in this case, okay, so this is a different problem. Determine whether the given number is a solution of the equation. Okay, so this is a very different question. Okay, in this case, they're asking us for whether this given number is a solution of the equation. Okay, well, the first thing I need to ask you is, what do you think about, what do you think the term solution means? And whenever you ask any person who hasn't taken any algebra at all, they're going to tell you that solution means the answer, basically. Okay, the answer of a problem. That's exactly what they're going to tell you. Like 100% of of people, if you go around, asking people, what does solution mean? If they haven't taken algebra, 100% of the people are going to tell you solution means the answer of a problem. Yeah, that's exactly what they're going to tell you. However, in algebra, mathematics, in this case, we're getting close to an introduction to algebra. We are going to introduce you to algebra in this class. So we're gonna be introducing it to you bit by bit. Like, for example, variables. We already introduced variables, right? Yeah. We haven't done much work with it, but we did introduce it. So we're gonna keep doing that. And in this case, we're introducing this word here, the term. So make sure you remember this word, solution. Right here it does mean the answer sometimes, but in algebra, whenever you're working with expressions like this, it doesn't mean that. Okay, and there isn't an exact translation. So I'm just gonna have to tell you what it does, or what it means, what it could mean, and then you use your own words. Okay, use your own words to give this your own definition. Okay. Determine whether a given number is a solution of the equation. Okay, so determine what number, the given number. Well, in this case, it cannot mean any of this, because remember again that this is an equation, and this comma is separating two thoughts from each other. Okay, separating this equation and this 16. Therefore, when they're talking about the given number, they talking about the 16 here. Okay, so determine whether the given number 16 is a solution of the equation. See, they even told you that this part here means this here, because this has an equal sign. Therefore, this is an equation. Now, see how they didn't tell you that this was an expression? That's because it's not. It's an equation now, okay? And we need to determine whether this 16 is a solution of this equation. Okay, how do we go about doing that? Well, we just plug in the value 16 for the variable here, and then work out that side of the equation and see if that makes the equation true. In other words, if this side turns into 9, then 9 equals 9 would make the equation true, right? If it doesn't, if it comes out to 12 or whatever other number, 12 equals 9 is not correct. So therefore, that 16 wouldn't make the equation true, okay? Well, let's see if it does. Okay, so let's go ahead and substitute that 16 into this y, into this expression here, this side, yeah. So 27 minus 16, that's 7 plus 4, that's 16, that's 7 plus 4. Oh, so I was right. Let me see. Well, let's go and work it out. Let me show you. 27 minus 16. Let me show you how you do it. Some of these problems are going to have solutions. Some of them are not. 27 minus 16. So let's see what this one worked out to. So let's say I believe it was subtraction. 7 minus 6 is 1. 2 minus 1 is 1. So see how 27 minus 16 is 11. Okay, let's go back over here. 27 minus 16 is 11. 11 equals 9 is not a true equation. It's not a true equation, therefore this 16 is not a solution of this equation, okay? Because it doesn't make the equation true, okay? So the answer is no. Not a solution. Final check. That's the correct answer, okay? Because 11 is not equal 9, okay? Okay, so let's go to the next one, and same kind of question. Substitute as a C for 2. Is it a solution? Is 2 a solution of this equation? Well, 2 times 9 is 18. 18 equals 18. That's true. So this equation is true when z equals 2, right? Therefore, this 2 is a solution of this equation, okay? So that's the definition of this term here, the word solution, okay? That's what they're referring to. So now you just use your own words to try to memorize it, okay? Solution of an equation is when a value makes the equation true. If that value makes the equation true, then that value is a solution, okay? If it doesn't make the equation true, that value is not a solution, okay? So now you have two meanings of the word solution, okay? The word you first learned your whole life, and now this one, okay? So now this word should have two meanings for you, okay? And in this class, we're going to use this word a lot, this meaning, second meaning, okay? So in this case, yeah, we said it was solution, so click on A, because 2 is a solution of that equation. So yeah, we got it correct. Click on the next one. Determine whether the given number is a solution of the equation. Okay, 56. Is 56 a solution of this equation? Well, let's substitute it for x. 56 divided by 8. 56 divided by 8 would be 7. Yeah, 56 divided by 56 divided by 8 is 7, because 8 times 5 times 7 is 56. That's how I know that, okay? So yeah, 7. So this side turns into 7. 7 equals 7 is true. Therefore, this number 56 is a solution of this equation. Okay, so yes. Is the given number a solution of the equation? Yes. All right, yeah. You got it correct. Okay, so that remember that that's what that means. Okay, that's what we mean by solution in this class anyway. Write sentence as an equation. Okay, so in this case, it's something similar to what we did before, except for before we were working with expressions. I don't know if you notice the difference. Okay, this time we're going to be working with equations. Okay, we're just adding the equal sign basically, right? Because an equation has to have an equal sign, remember? Okay, and the first thing I would do is determine where the equal sign is going to be. And in this phrase here, the equal sign would be here in the is, because I can see that 6 times a number, that means multiplying 6 times x, right? Is 48. So is the equal sign, okay? So 6 times a number, and I'm just going to go ahead and use this button here, times x equals, oh, and I can use this button too. You see it down here? If you want to use this buttons over here. 48. 48. And that should be it. Okay. So yeah, it's similar to what we did before, except for now we're working with equations. Just remember that an equation has to have an equal sign there somewhere. So make sure you go inside the sentence and see which word means the equal sign. Okay, that's I think that's a good start. That's where you can start, and the rest should come into place like really easily. Represent this as an equation. Okay, so we're doing the same thing. Yeah, a question of 27 and a number is 9. So again, I already saw where my equal sign should go. It should go right before that 9. And since this is a quotient, I need a fraction. 27 and a quotient of 27. And again, remember that whenever you're talking about quotients, you essentially transliterate it because whatever comes first is the numerator. Okay, so 27, and then hit the arrow button and write x for the missing value. Write the arrow, click the arrow button, and that should take you outside the fraction. Again, we said that is means equals 9. Click enter, and we got it correct. Click enter again. Let's keep going. Again, doing the same thing. The difference between 30 and a number is 8. The equal sign goes right there to the side of the 8. So I'm going to go ahead and treat this as an expression, this here. Difference between 30 and a number. Difference means subtraction of 30. Use the equal sign down here and a number, x, and then is means equals, right? And then 8 goes to the right there, and click enter, and then again, and that should take us to the next problem. Okay, we're doing the same thing here, and I'm just working them out to show you the examples. Okay, 6 less than 3 times a number gives 6. Okay, like I told you before, make sure you translate that equal sign first. So in this case, gives means equals. Okay, so equals 6 should be to the to the right is fine, or to the left is fine too, but I would put it in the right, so I wouldn't have to worry about this two words here. I would worry about this. How do you translate this? 6 less than 3 times a number. 6 less than, well, don't transliterate here, you know. Make sure with subtraction, make sure you translate it exactly as it is intended. Like in here, they told us to essentially to subtract 6 from 3 times a number. Okay, so 3. And I don't believe you have to write the multiplication sign. So I'm just going to write, in this case, 3x, just so you can see that it works. 3x minus, and I can use my keyboard, you know. And number gives means equals. And notice I'm using my keyboard, okay? So I can use that too. Here the first number keywords in a sentence operation. What happened there? So it did. Oh, what happened there? Minus 3x minus 6. Oh, there's supposed to be 2 6s in there, so not just one. All right, so we got it correct. Very good. Let's keep going. Again, let's practice with this one too. Let's see what the equal sign should be. 4 times a number is, there it is. See, so I worry about this separately and this right side separately, okay? So 4 times a number, means 4x, right? 4 times a number means 4x. Is means equals. Is equal to 35 decreased by a number. 35 decreased by a number, okay? So 35 minus a number. In this case, let the variable x represent the number, okay? So I believe we got it correct. Yeah. Notice that in this case, this x and this x were the same thing, see? Because they refer to a number to this same number twice. If they had meant to use a different number, they would have told us that. So be careful with that, okay? All right, next question. 9. Select either less than. Yeah, select either, this is a different question. Select either less than or greater than to make the statement true. Okay. So in this case, -9, is it less than or greater than 6? Well, if you think about the number line, it should be less, okay? So you use the less than button to answer that question, okay? That's all that is, okay? And then here, -30, no, 20, if you think about the number line, again, it's less than, okay? Less than 0, less than 0, yeah. Click next. And then, okay, so now we have a different value, different problem. Find the absolute value. Okay, there's another word that you need to learn. You need to memorize this word. I know it's a tricky word to memorize, but you're gonna use it a lot in this class. Well, not a lot, but yeah, substantially. And then in algebra, if you're taking algebra, you're gonna use it a lot. Okay, so the absolute value. Find the absolute value of this expression. In this case, the absolute value means these 2 lines here. Okay, these 2 lines here. It's just 2 straight lines. Yeah, vertical lines. 2 vertical lines, and that's how you represent the absolute value. Okay. And the absolute value of what? Well, whatever's inside, whatever expression you have inside, you're talking about that absolute value, okay? If anything is outside of that, then you're not referring to that, okay? The absolute value means the absolute value of whatever is inside the absolute value signs, okay? And what does that mean? Well, absolute value refers to number line. And let me take you to my document camera here. Absolute value means distance from on a number line from 0 to either positive or negative values. Okay. In this case, I believe it was 18. So the no, it was different problem. Anyway, I'm just gonna give you this example here. So let's say we had the absolute value of negative 18. What was it? What does the absolute value refer to? It refers to distance, and as we all know, distance cannot be represented as negative because, well, think about it. If you're looking at it from here to here, a distance is not negative. A distance is just a distance of 18 units. See? If you're looking at it from here to here, then the distance is just 18 units. So the distance is always positive, basically. Or think about the example of highway. So put yourself out in highway 20, I-20. Highway I-20, and then you're here, and then look to the right, and somebody tells you what's the distance from here to Dallas. That's 500 miles. Well, and then they ask you what's the distance from here to Abilene. Okay, the distance is 500 miles. Are you gonna say negative 500 miles? No, you're not. No, you're not, because you're referring to distance. See, so it doesn't make a difference where you are. When you're referring to distance, the distance always refers to positive values, okay? All right. So in this case, when you're talking about the absolute value, if you have a negative value inside the absolute value signs, the answer is going to be a positive value, okay? So in this case, they're asking you to calculate the distance on a number line from zero, starting from zero, moving negative 18 units. Negative 18 units. What is the distance? Well, the distance is 18, positive 18. Okay. Even though you landed over here, the answer is positive 18. Okay. Because it's referring to the absolute value. All right. Hopefully that makes sense, and you're gonna be able to answer all the rest of these problems. So let me go ahead and go back over here and to Pearson. And okay, there it is. See, if they're asking me to find the absolute value of negative 3, I need to think about the number line, and I need to know that absolute value refers to distance, and we all know that distance is always positive. So it doesn't make a difference where you are on the highway. If you're moving to the right, to the left, up, down, the distance is always going to be positive, okay? So in this case, the answer is 3. Because you're moving 3 units to the left, even though you land on the negative 3, absolute value refers to distance. Therefore, the answer is always positive. It's always positive. That means even if you have an absolute value of positive 3, the answer is still gonna be positive 3, okay? Because it's referring to distance. So don't make the mistake of let me go back over here real quick. Don't make the mistake of answering this question, absolute value of positive 3. Don't make the mistake, because students do make the mistake of writing a negative 3. Now that would be wrong, because remember, absolute value is referred to distances, and distances are always positive. So this would be wrong, okay? The absolute value of negative 3, it's also positive, okay? See, so the answer for these two are positive 3s, okay? Okay, so make sure you remember that, okay? Make sure you remember that, because that's gonna come up again. And it'll probably come up in the next example. All right, so let's just hit enter here real quick. Enter again. And yeah, here it is. So make sure you don't make a mistake of writing negative 16, okay? The distance refers to positive values. Click on next. Okay, so this is something different, okay? Because remember that the absolute values are surrounding grouping the 82, okay? So think about that. Absolute values are grouping whatever's inside the absolute value signs. In this case, that negative sign over here is not inside the absolute value sign. Therefore, it's not being affected. So the absolute value of 82 is what? And let me go back over here to show you. Absolute value. Okay, so absolute value of 82. Oh, I shouldn't. I'm used to writing parentheses. But anyway, the absolute value of. Oh yeah, make sure you remember that this is the absolute value sign, two parallel lines, and these are not brackets, because students make that mistake of thinking that these are brackets and they don't treat them as absolute values. Okay, this is not the same thing as this. Okay, these are absolute values, two straight lines. Absolute value of 82 is positive 82. And when you write the answer, omit the get rid of the absolute value signs. Yeah. And since we didn't do anything to the negative sign, go ahead and rewrite it. Rewrite it. So the answer is negative 82. You see that? So don't be tricked by that, okay? But that negative sign. All right. Let's go back over here to Pearson. So the answer should be negative 82. Click enter. Good job. Let's move to the next one. Okay, see here, we have negative signs inside the absolute value sign. So these negative signs are being affected by the absolute value sign. Okay, so how do we deal with this? Well, again, like I told you, the absolute value is also grouping. So think about it as being parentheses, because parentheses group, right? So make sure you think about this as this absolute value signs as being grouping, grouping this negative times negative 2. Okay, so one of the tricks I use here is to think about these negative signs as being multiplying signs. Yeah, multiplying signs. So use the rules for multiplying signs. So let me take you back over here to show you what I mean. Rules for multiplying signs. Multiply signs. Rules for multiplying signs. Okay, and you probably already know this back from high school. Well, whenever you multiply a positive times a positive, what do you get? You get a positive, right? That's a given. The only other time when you get a positive answer, when you if you're multiplying, is if you multiply two negative values. Okay. See, these are the only two times when you get a positive answer if you're multiplying. Okay. If you're multiplying two signs, these are the only two times you get a positive answer. Yeah, positive sign. Okay. Any other time, any other variation, like for example, you multiply positive negative or negative positive, doesn't make a difference. You're gonna get a negative sign. Okay, negative answer. Okay, so just make sure you remember this, and the rest should come into place easily. Yeah, it's not. I don't think the only difficult thing to remember is this: that a negative, when you multiply a negative times a negative, you get a positive. Okay, and the book does a good job at explaining to you this. So if you want an explanation as to why this happens, just look at one of those sections, one of those assignments. It's gonna be in there. Okay. All right. So like I said, if I wanted to if I wanted a trick, an easy trick to work with these signs here, just think about your multiplication sign, your rule for multiplying signs. Okay. So in this case, we said that if you multiply a negative times a negative, you get a positive. So what I would do here is I would turn that into, and let me kind of write it down really quick. That is problem 34, and that's the absolute value of negative 2, and close the absolute value there. So let me go ahead and go back over here, and now I'm here. Okay, problem number 34. This is the problem number 34. Absolute value of negative 2. Yeah. Theoretically, what's happening here is that you're saying that you're asking for the opposite value of negative 2. That's the way this will read. Okay, and that's one thing you need to remember, that this negative signs mean, or you can use the word opposite. I believe that's the way it's written. Opposite of negative 2. What is the opposite of negative 2? Well, the opposite of negative 2 is positive 2, right? So 2. You don't even have to write the positive sign there. So absolute. So you end up with the absolute value of 2, which is 2. Okay. Notice that here I use the opposite of, because you can also use the additive inverse, but that's more difficult to remember. Okay, additive inverse. Now, if you can remember that word, additive inverse, that's okay if you want to use that word too, but I don't think you're going to be able to remember this for the rest of your life. But if you can remember this word, whenever you see a negative sign, this is the word you're referring to. Okay, well, either of these two, but make sure this word pops in your mind. Okay, so in this case, we're saying the opposite of, or we're asking for the opposite of negative 2. Well, what's the opposite of negative 2? Well, the positive 2. See, and that gets rid of these signs. Okay, so that's one way of answering that question. But like I told you, to me, it makes more sense to use this the rules for multiplying signs, because we're gonna use it a lot. I mean, we're gonna use this the rest of the semester. So might as well, start using them here. Okay, so this is what I'm gonna tell you. Whenever you see two signs together like this, without any values in between, go ahead and use these rules. Okay, you hear that? Because we're gonna use that a lot. This is gonna come up a lot in this class. Okay, this kind of scenario. Even though this is talking about subtraction, or the opposite, or the additive inverse of, we can use these rules and they're still gonna work fine. Even though theoretically this is not what's happening. I mean, it is, but you could think about it as using these rules to speed this up, speed up this process. So in this case, if let's say I haven't worked it out yet, and if I was here and I saw these two signs together, I need to think about my rules for multiplying signs. Well, two negative signs give you what? Positive value. There it is. Therefore, I could just go from here to here and then to here, because the absolute value of 2 is a positive 2 is just positive 2, or just 2. So that should be the answer. Okay. All right. Hopefully hopefully I taught you everything you need to know about that. Okay. And I know I'm teaching you a lot of extra stuff, but that's because we use it a lot in this. If I'm not teaching it to you, it's because we don't use it. Or it's because when are you gonna use it much? But in this case, this is stuff that we're gonna use a lot in this class. So the answer is 2. Click enter. That's correct. Going to the next one. So don't let this signs trick you. Remember that absolute values group, parenthesis group 2. That's not a problem. In this case, we have two groups, the absolute value and the parentheses. And like I told you before, whenever you have more than one parentheses, more than one grouping, you need to start from the inside out, okay, from the innermost, and work your way out. So in this case, the absolute value of negative 13, and let me write it down because I need to work that one out. That's problem 35. 35, put inside the box, negative, open parentheses, negative absolute value, negative 13, and close the absolute value and close your parentheses, and that is it. So let's go back over here to my document camera very quick, and now we're here. All right, like I said, we need to work inside the innermost parentheses or grouping and rewrite everything else. Okay, negative parentheses, negative absolute value of negative 13 is what? It's got to be positive 13. Okay, that gets rid of the absolute value signs, close parentheses, which is this over here, and now we're here. Okay, so what do you see here? Well, I see two signs together. What did I tell you that shortcut was? To think about the rules multiplying signs. Negative times a negative gives you positive. Then the answer is 13. Okay, even though I wrote a positive sign there, it was just to show you that these two signs turn into a positive sign. However, the computer is not going to take this positive sign in there. So you need to get rid of that and write a 13 instead of a plus 13, okay? Because this is not simplified enough, okay? And remember that in algebra and mathematics, you need to simplify as much. Every time you're working with any problems, you need to simplify as much as you can. So make sure you do that, okay? Okay, so we did say it was a 13, right? Let's see if we got it correct. Yeah, that was it. So don't let those signs trick you because, don't let them trick you because as long as you follow the rules, you should be okay. Because now you need to use either less than, greater than, or equals signs in between here. Okay, so here, in between these two. So which one is larger? Well, absolute value of 14 is, or negative 14 is 14. Go ahead and include that sign because we haven't done anything with this sign. So this left side is negative 14. What about this one? I have two signs together. Negative times a negative gives you a positive. So the answer is positive 14. So we have negative 14 on the left, positive 14 on the right. Are they equal to each other? No. Is the first one less than the second one? Yeah, it is. So we need to use, and for that I need to go down here to the negative, to the less than sign. And I wonder what happens if I click on that. Oh, less. See, if you're trying to well, in this case, they gave you the right all the buttons that you needed. Okay, so I was thinking that they would probably not show them to you, and then you had to click on the more button there. If that happens, yeah, just click on the more button, and it should show you the rest of the buttons here. Okay, so we said it was less than. All right, click enter. Yeah, that was the correct answer. Okay, so don't let those signs throw you for a loop. And yeah, I know I worked out all those problems, the absolute value problems, but that's because we used that knowledge. I wouldn't say a lot, but we do use it in this class again. Okay. Find negative x when, okay, so this is a different problem. Find negative x when x equals negative 13. Well, it's similar to the other ones. All we have to do is substitute negative 13 here for the x. Now you end up with 2 negative signs. Remember what I told you to do when you have two signs together? Use the multiplication rules for signs. So a negative times a negative gives you a positive. So the answer should be a positive 13. Click enter. Got it. Okay, fill in the blank. Fill in the blank. Oh yeah, no, these are this problems, this kind of problems are easy. I don't know why you guys keep missing this problem. You have a lot of trouble with these kinds of problems. I don't know why, but all this means is that whenever you get a loss, that means you're subtracting, right? Whenever you get a gain, that means you're adding, right? For example, here, if you get a loss of $5 followed by a loss of $4, aren't you missing $5 first, and then you're gonna miss again $4? So then you have to add them together and count them as a loss. So 5 plus 9, I mean 5 plus 4 is 9. So let me go here. So this, I know this is gonna be a loss, right? Because you never gain anything. I know there's gonna be a loss of how much? Well, you lost both of them, right? You lost both of them, so we added them. They added up to 9. So that's the way you answer those questions, okay? And we're not gonna see this again, so this is the only time we're gonna see it. Is here. I'm not gonna include this in the this kind of problems in the final. And so what would that look like? Well, a loss of 5 means negative 5, right? And then a loss of 4 means negative 4, right? So let's go ahead and see which two expressions. Only this one has both 5 and 4 as negative values, right? So this should be it. And that's okay, because look at this. If we had two signs together, what do? We think about multiplication rules for signs. What do we say? We get when we multiply a positive times a negative, or a negative times a positive, we get a negative sign. So this means negative 4. So negative 5 minus 4 is negative 9. So this should be the answer. And then negative, did we say? Yeah, negative 9. Yep, that was it. Next question. Oh, notice how here the second part the answer was negative 9, but here the answer was 9. However, we did include that negative sign as a loss over here, so that was the difference. Okay, and this was just supposed to introduce you to integers, guys. It wasn't supposed to be that difficult, even though it turned out to be. I see students struggle a lot with that. I don't know why. Anyway, next question. Again, gain means adding or positive sign. A loss means subtracting or a negative sign. If I have a gain of 20 and a loss of 22, well, isn't that gonna cancel out and get you negative 2? Yeah, that this 2 is gonna cancel out, and you're gonna end up with a loss of $2. So you end up with a loss of $2. And how would you write that? Well, again, like I said, gain is positive 20 and a loss is negative 22. So the only one, yeah, the only one correctly is this one, because I have a positive 22 and a negative 22. And positive and negative gives you a negative value, and when you add them together, you end up with a negative value. All right, keep going. Okay, so find the sum using the number line. Here, for this kind of problems, we have number line, okay? And this was supposed to teach you how to add negative values, okay? So let's see if we come up with any of those. Move the point to the number line. Okay, find the sum using the number line. Okay, and I know you can do this in your head, but there were a few problems where we had to use number line because they were introducing addition and subtraction, okay? So in this case, again, start by changing the signs. This is positive and negative. That should give me a negative sign, right? So 10 minus 3. 10 minus 3 is positive 7, right? 10 minus 3 is positive 7. 7 is right here, positive 7. Oh, I believe I have to drag my point from 0 to 7. Yeah. Check my answer. Yeah, that's the answer. That's how you do it, okay? Again, find the sum of using number line. Okay, -5. I have a -5. If I have a -5. Oh, that's my 0 line. -5 is way over here. I mean, -7. -7 right there. And then plus 5. Plus 5. So all this is whenever you see a negative value on a number line, you move to the left. Whenever you see a positive sign on a number line, you move to the right. Okay, so in this case, we moved 7 units to the left first. Now we have a positive 5. We need to move to the right 5 units. 1, 2, 3, 4, 5. So we end up right here. So we need to move our point up all the way to here. And that should be the answer, okay? And that's how you add on a number line, okay? That's how you add on a number line. More than likely, you can do this in your head. But that's only because you have small values. Once you're working with larger values, it's not as easy to do in your head. Anyway, find the given sum. Again, I will start by changing these signs. Positive and negative gives you a negative. -7 minus 2. In that case, you add both. So you have two signs that are the same. And then you skip the sign. So in this case, 7 plus 2 is 9. Oh, well, I'll tell you what. I'll type it in there. 9. And then you keep the sign. I'll go back over here and write the sign there. And that should be the right answer. Okay. Okay, so notice how I did that. I knew these two values were negative. So on a number line, if you plot them on a number line, you're going to move to the left 7 units plus 2 more units because this -2, this 2 is negative also. So that's why I added them up and then just kept the sign. And that's the way I like to say it. Just keep the sign. That's the easiest way for me, to say that. But you can use your own words there. So add them up, keep the sign. Okay. Let's see if they have another one there. This no, they didn't. Okay. Well, this is different because this -19 plus 5. Okay, so we are adding here. Okay, we're not subtracting, we're adding. However, we're adding a negative value plus a 5. Well, if you think about the number line, you're gonna move to the left 19 units first. That's gonna put you over in the negative values, and then you're gonna move 5 to the right. You're still gonna end up on the negative values. However, move you back 5 units, so that's 14, -14. So you're gonna end up on -14 if you're thinking about the number line. Okay. Now, if you're thinking about and let me just type it in there, -14. Okay, so that was the right answer. And now let me go ahead and work it out by hand. So you see how I did it on a number line? So those are two ways of doing it. These are going to be two ways of doing it. That was negative 19. That's problem 43. That's 19. That's 5. Oh, okay. How do I do this by hands? Okay, let me show you. 19 plus 5. I'm right here. How do I do this by hand? Anytime you have only one, anytime you only have one sign that's negative, you have subtraction. Okay, so when you have two values and one of them is negative, so it doesn't make a difference which, you have subtraction. Okay, because otherwise, if both of these were positive, you have to add them up. Otherwise, if both of these were negative, you will still have to add them up. Remember, because both of them are going to be negative. You will still add them up and just keep the sign. So whenever you have two signs, two alike signs, you add them up and keep the sign. So if you had two positive values, add them up, keep the sign. If you had two negative values, add them up, keep the sign. And that's the trick to that, okay? Now, whenever you have only one sign, doesn't make a difference which, go ahead and subtract. And I know you could probably do this in your head, right? But we need to practice doing by hand because sometimes we have to work with larger values, okay? So in this case, like I said, we need to subtract. Okay, so in this case, every time you have two values, write the largest value at the top. Okay, so that's the rule. Okay, if you want to do it this way, that's the rule. I know I'm subtracting, therefore I need to write the largest value at the top. Otherwise, if you do it backwards, if you write 5 minus 19, well, you end up running into problems. See, you're gonna end up with what? Negative values here? Yeah, no, that's not gonna work. Okay, so every time you have subtraction, write the largest value at the top and then subtract. And we'll worry about the signs later. Okay, so 9 minus 5 is 4. 1 minus 0 is 1. So in this case, the answer is 14. And then I go back to my original expression and look at the signs. And the sign of the largest value stays. Or like I said before, you keep the sign of the largest value. Okay, and that should be the answer. 14. And yeah, and we got it correct. We got it correct both times. Okay, remember we worked the number line. Yes, it was negative 14. When we worked it out by hand, the answer was also 14. Okay, negative 14. Okay, so we did get it correct both ways. All right, so let's see here. This is different now. Find the sum. I believe we already. Yeah, just work this one out on your own because all this is working with order of operations. Yeah, because that's you're supposed to work inside here. The absolute value of 17 minus 15. That's 2. Absolute value of 2 is just 2. And then include this negative sign there. So that's negative 2. So this bracket becomes negative 2. And then negative 12 minus 2 is negative 14. So the answer should be negative 14 there. Let's see. We got it correctly. Yeah. Okay. So that was nothing. It was. That problem is in there because we're still working with order operations. Okay, and we're working with additions and subtractions, which, like I told you before, we worked on shortcuts by looking at additions, subtractions, whether you have two signs together or not, you either use the rules for multiplying signs or not. Okay, in this case we did here, and that's how I that was a shortcut. That was a shortcut we used there. All right, so let's go ahead and work on the next one. Proof indicator subtraction. See, we're working additions and subtractions. So in this case, 18 minus 2. Well, 18 minus 2, we know that it's, the answer is 17. I mean, 16. If you wanted to do it by hand, again, see how there was a positive value there and negative value there? That was a subtraction because we only had one negative sign. If you wanted to do that by hand, write 18 at the top, 2 at the bottom. Keep the place values together. The 8 goes over the 2 because those are the ones values, and then just subtract. You should get the same answer. Okay. And then subtract here. Again, we only have one positive value, one negative value. 3 minus 16. This time I'm gonna have to work it out really quick, just so I can show you what I mean. Oh, what was it? Negative 1? Negative, no, 3 minus 16. Okay, so we have 3 minus 16. I know that's a subtraction. Again, every single time you have subtraction, do write the largest value at the top, smallest value, subtract. 6 minus 3 is 3. 1 minus 0 is 1. The answer is 13, except for now we go back and look for the signs, and then look at the sign of the largest value, keep that sign. So the sign was, that 16 was negative, keep that sign. The answer is negative 13. Okay, that's how you do it by hand. Okay, all right. And I know these are very simple problems, but I'm telling you, these problems are going to get larger and more complicated. So that's why you need to use the rules here and learn them here. Okay. So we said it was negative 13, negative 13. Good. Okay. Proof indicator operation. We're subtracting a negative value. Okay, or the opposite of negative 14. That's one way of looking at it. Or you could think of these two signs together as being a positive, right? Because when you multiply a negative times a negative, you get a positive. So 5 plus 14. So that's an addition. Yeah, it turns into an addition instead. 14, that's 19, and that should be the right answer. Okay. I'm not going to worry about that one. Subtract. Okay. Again, I can see two signs together. That's go ahead and use the shortcut. Negative times a negative give you a positive. That's negative 5 plus 17. In this case, you end up with negative 5 plus 17. And let me go ahead and write down really quick. Negative 5 plus 17. So we can work it out. 48. Let me take you back to my document camera over here. Okay, again, there's only one negative sign here. Therefore, this is a subtraction. Again, always write the largest value at the top. Go ahead and subtract. 7 minus 5 is 2. 1 minus 0 is 1. The answer is not that, because we still have to look at the largest value over here and keep that sign. Okay. In this case, 17 was positive. So the answer should be positive. So positive 12 should be the answer, except for we simplify that to 12, right? Yeah, I'm just showing you that this sign came from here. So that's not the answer. This is the answer. All right. All right, let's move on. And I'm not worried about typing it in. Okay, so again, all of this is just using practicing addition and subtraction. Okay. Again, I will start by changing these two signs, and then starting from left to right. Remember that you can What was that? Let me take you back here to my document camera. Remember again that addition and subtraction, whichever comes first from left to right, go ahead and perform that operation, okay? So in other words, if addition comes first, go ahead and perform that operation. If subtraction comes first, go ahead and perform that operation, okay? So these two scenarios are good, okay? Make sure you remember that, okay? So let me go back up here. And in this case, you will go to the left here and start working with 10 minus 46. Rewrite everything. And tell you what, let me go ahead and just work that one out because you need to be familiar with well, I mean, I did work out a problem like that, and before several actually, and let me write this down real quick. 46, but they didn't have any. They have that many additions or subtractions, and I need to work on that because that's where students make mistakes with addition, subtraction, and multiplication, division. Whichever comes first, you perform that operation, okay? Okay, so let me take you to my document camera real quick. So now I'm here. Okay, again, like I told you, if you wanna go ahead and change the signs first and write everything else down, because you're not saving time, you know, if you don't, yeah. See, that didn't take me long. How long did it take me? 2 seconds, maybe? Anyway, now I'm here. Because negative times a negative, give me a positive, okay? Again, go to the left. I don't have any parentheses, no exponents, no multiplication, no division, only addition and subtractions, okay? So from left to right, I have a subtraction there, 10 minus 46. Again, write the largest value first, and then the smallest value. Subtract 6 minus 0 is 6. 4 minus 1 is 3. So 36. Go back. Look at the largest value. See the sign? That's negative. Go ahead and keep that. So the answer here is negative 36. Okay. And I know you can do that in your head, but we need to practice. We need to practice because, like I told you, we are gonna have the problems are gonna get larger and larger, and you're gonna have to do it in your head too. So make sure we write everything else. Now I'm here. Okay, from left to right again. You only have addition subtractions. So these two values, I need to add them together. That is an addition. Well, no, actually it's a subtraction because we only have one sign, one negative sign. Okay, 36 and 18. Which one's larger? 36. 36. Write that one down first. Subtract 6 minus 8. That's gonna give you a negative value. That's not gonna work. And this is when you borrow from the left. Okay, so since this is a 3, you need to borrow 1 unit from here. Make sure you cross this one out because now that turns into 2 when you borrow. Okay. Now notice that 1 unit from here is worth 10 units from here. Therefore, if you add 1 unit from here, it turns into 10. 10 plus 6 is 16. So I just write a 1 there. That becomes 16. Okay. You can do it. You can do it that way too, or you can cross this out and write 16 up here if you want. Whatever works best for you. I've noticed that this works every single time for me anyway. So this time I have 16 here. 16 units minus 8 is 8. 2, not 3, but 2 minus 1 is 1. Okay, that's 18. Therefore, well, I need to go back to my original expression here and look at the sign of the largest value. That's negative. So, well, the answer for this step here is negative 18. Okay. Negative 18. That takes care of those two. Rewrite everything else. Negative 36 plus 18. Negative 18. Yeah. All I have is addition subtraction again. From the left, I need to, well, in this case, subtract two negative values. What do you do when you subtract two negative values? Well, you add them up. Okay, that's the fastest way, because you're gonna end up on negative values on the negative side if you're on a number line. Remember. So let's go ahead and add them up. Let me go ahead and introduce an addition here, because we're gonna need to use the know the rules for adding by hand. So in this case, 8 plus 6 is 14. So 4 and carry the 1. 1 plus 1 plus 1 plus 3 is 5. All right. So and since both of the signs were negative, the answer is negative. Okay. Notice that here, and this is where students also make mistakes. Since I said that both of these signs were negative, the answer was negative, they are thinking about multiplication of signs, but that's not what this is. Okay, this is rule for adding and subtracting values. Okay, in this case though, we're subtracting two negative values, which are going to align you on a negative on the negative side of a number line. So negative 54. I use both of those, get rid of them, rewrite everything else. Now you're here. Okay, so I have a negative value and a positive value. That means subtraction. Again, write the largest value at the top always. Write the ones values on top of each other, tens value on top of each other, and so on. Okay, because with subtraction and addition, it matters. Okay, so in this case, 4 minus 8 is going to give you a negative value. Therefore, you need to borrow from 5. If you borrow from the 5, make sure you compensate for that by writing a number 4 up here, okay? And really quick, yeah. This becomes a 10 plus 4, 14, right? So 14 minus 8 is 6. 4 minus 1 is 3. And go back over here to the original expression. Make sure you don't skip this step, okay? You're gonna be working out, if you're gonna be working out this way, then at the end, make sure you always take care of your sign, okay? So go back over here, look at the largest value, that's a negative, the answer should be negative, okay? So negative 36. So the answer is negative 36, okay? Okay, and that's the way I would go about working out one of those problems, okay? So hopefully that got it. Hopefully that did it, because I know I'm gonna have we're gonna have other problems like that again. Just make sure you use the same process I used in the previous problem, and you should be okay. Let's see what else. All right, this is a different problem. Translate the following phrase into a subtraction problem. Then find the difference. Okay, so well, in this case, you need to find you need to write this as a subtraction problem. This is a little bit tricky, because you have a negative 19 subtracted from 12. Subtracted from 12. Subtracted from 12. Well, let's see. Oh, so they gave it to you. They gave you different choices. I was about to write down, but since they already gave us some choices, let's see what this means. Negative 19 subtracted from. Okay, notice that here it doesn't say negative 19 minus 12. That would be a big mistake. It says you're subtracting that from 12. Therefore, the problem should look something like that or like that, because you're subtracting, say, you're subtracting from 12. You're subtracting from 12 here too. Okay. Then the other clue is that negative 19. You're subtracting negative 19. Okay. In this case down here, we're subtracting a positive 19. See? So these two, even though they look the same, they are not the same thing. Here, you are subtracting negative 19. See that? That's a big difference. Here, you're subtracting negative 19. Therefore, that should be the answer, okay? The correct answer, yeah. Not the other one, okay? So be careful with that. Yeah, it's a bit tricky. So the difference is, well, then you just work it out, right? Negative times a negative gives you positive. Add them up, and that should be your answer, okay? All right, let's move on. Yeah. Translate the form. Again, similar to the other one, 60 less than negative 30, and they give you choices. 60 less than negative 30. 60 less than 30. 60 less than 30. 60 60, yeah, these two, 60 less. In other words, subtract 60 from negative 30, right? 60 from, subtract 60 from negative 30, subtract 60 from negative 30, that's that one. Because this is negative 30. You're subtracting 60 from negative 30. So notice how they didn't say 60 from negative 30. They said 60 less than. So they worded it, they could have worded it different, two different ways, okay? So watch out for those negatives and subtractions and less thans, okay? All right, let's move on, because all you have to do there is just, oh yeah, and remember that, well, notice that, like if you're working out on your test and you go like this and you see a box like this, that probably means you missed the second part, okay? So make sure you read through that box and don't miss the second part. So you don't have any excuses, really. If you miss the second part there, you either did it on purpose or didn't have time or whatever. But yeah, if you see this kind of box here, that probably means you missed the second part, okay? In this case, we're just gonna move on, okay? Okay, so see, this is why I taught you multiplication of signs, the rules for multiplying signs, because I knew we were going to use them again, and we're going to use them a lot. So in this case, we have a positive 7 times a negative 2, and we have positive and negative. We're going to get a negative value, right? And make sure you practice your multiplication tables, okay? I gave you a link to a website that where you can practice multiplying different kinds of tables, okay? All right, so here we have two negative signs. I know I'm going to get a positive answer. 9 times 7 is 63, and it's positive because now we are multiplying, okay? We are not adding. Now, if we were adding, then yeah, the answer would be negative, right? So be careful when you add, when you go from adding to multiplying, and when you go from multiplying to adding, okay? Because those are two different rules. We need to use two sets of different rules, okay? All right, so perform the indicated multiplication. Again, a negative times a positive gives you a negative. So the answer should be negative 8, okay? For the following product, negative times a negative gives you a positive. 10 times 1 is positive 10. All right. Perform the it's still the same. Well, and in this case, they added a few more products there. But work from left to right, you should be okay. In this case, a negative times a negative is a positive, positive 12. And then positive 12 times a negative 1, you get a negative 12. Negative 12 times a positive 13. You get a negative 36. And yes, it should be negative 36, I think. Anyway, let's move on. Evaluate the exponential expression. Okay, yeah, exponential expression. Okay, so in this case, we are practicing this because notice that this parenthesis, again, parenthesis group, either group or they multiply, okay, or they're saved as a multiplication, right? So in this case, they are grouping. What are they grouping? The negative sign and the 8. So the negative sign and the 8 are affected by the exponents, okay? Negative sign and the 8, all of that together is affected by the exponents. Therefore, let me go back over here. That's negative 8, inside the parentheses. Right. Okay, so since we said that this is, the whole thing is together, right? The whole thing is the base then. Therefore, you write the base twice, right? And then just multiply. See, you write it twice because of the exponents, and then just multiply. Right? Yeah, because in this case we're evaluating. Okay, so I multiply 8 times. I know I'm gonna get a positive answer because I'm multiplying, and I'm multiplying 2 negative signs. 8 times 8 is 64. Well, positive 64. Okay, positive 64. Okay, it's positive 64. Not negative, because we're multiplying now. Okay, and that should be the answer. Type in 64 and you're good. Okay, so here's a difference. So don't get fooled by the differences in exponential expressions. Negative 9 squared. So now we have a negative 9 squared. That 2, the exponent of 2, is not affecting the negative sign. See, because you don't have parentheses that are grouping them. Okay. Therefore, the base of the power of 2 is 9, not negative 9. Okay, it's not negative 8 like it was here. This case is 9. Therefore, I write 9 twice, multiplying together. That equals 81. And then, since we didn't do anything to a negative sign, we need to include that in there. See, we need to go back in there and include in there. So the answer should be negative 81. Okay, not positive. Not the answer is negative, not positive like it was over here. Okay, notice the difference. Okay, this time the parentheses were grouping the negative sign and the 8. This time we don't have any parentheses here. Therefore, the exponent was only affecting the 9 and not the negative sign. All right, so just type in negative 81 and you should be okay. All right, evaluate the following expression. Okay, in this case, okay, that's a different scenario. So I'm gonna go ahead and work it out. It is negative 3 to the positive, and let me go over here to my okay, so again, the base is negative 3, not just 3. Okay, so write down negative 3 times, because that's the exponent. So the exponent tells you how many times you have to write down, then just multiply. Okay, that's easy. Start from left to right. These two are two negatives that are going to give you a positive answer. I'm done with those two. 9 times a negative 3 is going to give you a negative answer, because positive and negative gives you a negative. 9 times 3 is 27. So the answer is negative 27. Okay, negative 27. Let me go ahead and work out another example here. What happens if this exponent is 2? Well, and I know I have one of these problems in the review, but I'm gonna go ahead and work it out here. Okay, so I have a negative 3 twice, multiply together. Negative times a negative, that's gonna give you a positive 9. Notice how the answer is positive when your exponent is even, and your answer is negative when your exponent is odd. And that happens when that only happens when the parenthesis is grouping the negative sign in there with the value. Okay, because notice that if you had, let me rewrite that without the parenthesis. See, notice that now we are not affecting that. That 3 is not affecting that negative sign. So you write 3 times 3 times 3 times 3 is 9. 9 times 3 is 27. 27. We didn't do anything to that sign. The answer is negative 27. Even though we did get the same answer as here, watch what happens if I multiply this without the parentheses. Okay, that means this 2 is only affecting that 3. So multiply 3 times 3. That's equals 9. But then we didn't do anything to the negative sign, so you need to include it in here. Well, let me rewrite over here. The answer is negative 9. Notice that difference there, and that's because we didn't include the negative sign in with the value there, because we didn't use parentheses. Okay, so this, what we did here, it only works when you're including the negative sign there. Okay, every time you have an odd exponent and you multiply a negative value and your base is negative and your negative value, then you get a negative answer. If your exponent is even and your base is negative, then your answer is always positive. However, here your base is not negative. Your base is positive. Here your base is also positive, except for we wrote this sign at the end there because we didn't use it. So that's the difference. Okay, maybe that makes some sense. Okay, and yeah, I know we're not going to use that knowledge too much, but I just thought I'd throw it in there because we are going to use it in this test and on the final. Okay, that might help. So let's see, and I just told you that because that could be a shortcut. You don't have to use it, but it could be a shortcut if you practice it enough. Evaluate the exponential expression. Okay, again, see, this is what I just worked out. Okay, because now I have a negative base and an odd exponent. That means you're gonna get a negative answer. Okay, always. So in this case, the answer is negative 1. Okay. All right. In this case, this 14 is not affecting the negative sign. Therefore, 1 to the 14th power is 1. And then just rewrite it, rewrite the sign. The answer is negative 1. Divide 72. Okay, so here we're dividing now. And the rules for the signs of whenever you're multiplying signs, whenever you're multiplying values. So the rules for signs, they apply to division too. Okay, The rules for multiplying signs apply for division too. All right, hopefully that makes that clear. The signs, the rules we just learned, they apply for this too, okay, for division. So in this case, I'm dividing a positive and negative. I should get a negative answer, okay? 72 divided by 8, that's 9, except for the sign is, since I'm dividing, the sign should be negative, okay? So the answer should be negative 9, okay? And that's it. Okay, again, we're dividing, except we're using the rules for signs. Negative divided by positive should give you a negative, okay? Negative value, 32 divided by 4, I believe that's 8, okay? So the answer is negative 8, okay? Okay, so in this case, we're dividing 0 by some number. And the rule for that is that whenever you're dividing 0 by any number, you are going to get 0, okay? So it doesn't make a difference which value you divide by. If you're dividing 0 by any value, the answer is 0, okay? So the answer should be this, and the answer should be 0. And I'm just making that a point because, watch, now we're dividing by 0. So those are two different scenarios. Once you're dividing by 0, the answer is undefined. Okay, so that's, and you need to learn this, okay? You need to learn the difference between these two. I don't care how you do it, but you have to, okay? If you only want to memorize the previous problem, you know, the 0 divided by any number gives you 0, and then anything else should be undefined, right? You can do that. What do I mean by that? So we are in problem 67, 65. So let me go back to 65. Oh no, yeah. So 0 divided by negative 12 is gonna give you 0. 0 divided by any value is gonna give you 0. If you just wanna remember that, memorize that, and anything else, any other variation, like any value divided by 0 is gonna be an undefined expression, okay? Okay, so the way I remember it is by memorizing that 0 divided by any value gives you 0, okay? 0 divided by any value gives you 0. In other words, 0 over any value gives you 0. 0 divided by any value gives you 0. All right? And then anything else would be undefined. All right? Hopefully that makes sense. Let's come back to 67. What is negative 5 squared? What is negative 5 squared? Negative 5 squared. Simplify your answer. Negative 5 squared. Negative 5 squared. For this kind of problem, you have to write down. Let's see, negative 5 squared. So find your answer. 5 squared times 25. Let's do 25. Yeah, because negative 5 times negative 5 is going to give you a positive answer, okay? So what is negative 5 squared? So that means when you write it down, you're going to have to include parentheses, okay? Because it's talking about negative 25. What is negative 25 squared? That's what they mean. This is not what they mean. Because then this becomes, what is 25 squared? Negative 25 squared. What is negative 25 squared? What is negative 25 squared? What am I trying to say? What I'm trying to say is that this means this, this, and this means this. 25 times negative sign there, and times positive 25. That's what that means. So those are two different things, okay? So watch out for that. All right, let's move on. And I believe we are almost at the end here, okay? Use your operations to simplify the expression. Well, I could work out some of these problems, but let's see what else we have. Yeah, all this is auto operation. Remember, we're just grouping up here, grouping down here. Work out the numerator first, denominator next if you want, and then just continue on until you evaluate everything and simplify everything as much as possible, and you should be okay. I don't see anything out of the ordinary there. It's just you're multiplying here using multiplication signs, the rules for multiplying signs there. Here you just have an exponent there, negative exponent, negative value, negative base, an exponent there. Here you have an exponent. That's it. No, there's nothing new there that you haven't learned. Let's see what else here. No, this absolute value is grouping. Just grouping that. So work inside there first. Notice that here, this -3 and this -3 here, we're multiplying them together because of this parenthesis, okay? That's what it's saying, okay? So watch out for that. Even though we don't have a multiplication sign there, that's what we're doing, okay? So that operation should be performed first, and then you add that to -15. And then get the absolute value of that, and work on your exponent next. Work on this exponent, and then add here and subtract and then add. And yeah, there's nothing that we haven't practiced. But if you still have any problems, any doubts, you let me know. Evaluate the given expression for x equals -3. Again, see, we worked out a few problems similar to this. Whenever you need to evaluate, you're not going to end up with a variable, okay? Because you're not solving, okay? You're not solving, okay? Hopefully, I made that very clear. Evaluating and solving are not the same thing. All right. So x equals -3. Just substitute x equals -3. Oh, well, this is one of those problems where students make a lot of mistakes. So let me work this one out, because x equals -3 means exactly that. Means x equals -3. Okay. Let me go ahead and write down the problem first. Plus 4x plus 11. And let me take you to my document camera here. And now we're here. When x equals -3, that's exactly what that means. That means x equals -3. The whole thing, okay? So even though it's not inside parentheses, the -3, think about it as being inside parentheses, because x equals whatever is on this side, okay? So this equal sign is grouping that right side. That's what it's doing, okay? Even though you don't think about it that way, that's what the equal sign is doing. It's grouping whatever's on the left side, and it's grouping whatever's on the right side. Therefore, it is okay to write parentheses around the -3, around the negative sign and the 3. And then, so that's good, because when we substitute the x, the -3 for the x here, watch what happens. If we don't write parentheses, what happens? See, If we substitute this x for negative 3, well, what ends up happening is just we now have 3, positive 3 to the second power, right? And this sign is excluded. This power of 2 is not affecting the sign now. Okay? But that's not what we want. X equals negative 3. Therefore, you need to keep together, okay? You need to keep the negative sign and the 3 together. So now this power of 2 is affecting the negative sign, okay? The power of 2 is affecting the negative sign. Rewrite that 4 there. Multiplying times x, which is negative 3. Again, if we didn't have this sign, we would have to include multiplication sign here, or I guess we could too. That's fine. But this parenthesis, I got it from here, okay? And this is okay. Even though we didn't have to write this sign here, because remember that parentheses also mean multiplication. Well, sometimes mean multiplication. In this case, it does mean multiplication, okay? All right, rewrite that positive 11 there. And start working from left to right. In this case, we only have one exponent, negative 3 times negative 3 is positive. Remember, a negative times a negative gives you positive 9. Positive 9, positive 9. In this case, we were multiplying this negative 3 times this, but we didn't have a sign. Okay, we didn't have a sign there. However, that's what that means, positive 9. And then plus 4. Okay, so let me go ahead and write the rest of this down like I've been telling you. Now I'm here. Okay, so let me go ahead back to the left. Negative 3 times 9 is positive, negative 27. And then plus 4. I'm just rewriting everything else, times negative 3 plus 11. Go back to the left. I have multiplication here. Rewrite negative 27. And then this becomes negative, because positive times a negative is going to give you a negative. That's negative 12. And rewrite plus 11 there. Go back to the left. I have 2 negative signs. Therefore, I add them up. 20 plus 27 plus 12. Well, I wanted to do that in my head. I'm just adding 20 plus 10. That's 30, 37, 38, 39. 39. Since both of these are negative and I'm adding, I'm gonna end up on the negative side of the number line, right? So my answer is negative. Rewrite everything else. Plus 11 there. Now I'm here. Now I have a subtraction because I only have one negative sign there. Write the largest value at the top, smaller ones at the bottom, and subtract. Keep the ones on the ones column and the tens on the tens column. Okay, that's important. 9 minus 1 is 8. 3 minus 2 minus 1 is 2. And the answer is 28. Okay. And then make sure you always take care of the signs at the end. So go back to your original expression. Look at the sign of the largest value. It's negative. So the answer should be negative. Okay. 28. So the answer is negative 28. Okay, so that's how you will work that one out, that kind of problem, right? And notice that it says to evaluate. So even though this looks like algebra, that's not what you're supposed to do, because it's not asking you to solve. Okay, it's not asking you to solve. Those are two different things. All right, let's move on. And then evaluate the following expression for the given value of the variables. Okay, again, even though we this looks like algebra, it isn't, because you have to evaluate. You substitute the values of x and y into this expression. See, it's not even an equation; it's an expression. Okay, and then just use the order operation and write the answer in there. All right. Determine whether the given integers, the given integer is solution of the following equation. What is the given integer? Well, again, you need to look at your comma, because comma separate two different expressions. Well, two different. In this case, well, in this case, two different expressions. Well, yeah, two different expressions, because -7 could be considered an expression too. In this case, though, it's the integer, given integer. Okay, and in this case, comma is separating this side, this equation, and this integer. All right. So in this case, they are asking us whether this -7 is a solution of this equation. What does that mean? What does solution mean? Besides the regular definition that we use for it. Well, here, remember that you need to plug in the value and evaluate, and then see if that integer made the equation true. Okay, if it does, then it is a solution. If it doesn't, then it's not a solution. Okay, that's how you solve the problem. Okay, all right, and that's the end of that. Okay, let me just go ahead and show you this again, the drop-down menu. See how we skipped a lot of questions? See, so if you skip questions, this is how it's going to look like. Okay, it's going to look like red, red ink everywhere. Okay, and this is what it looks like when you skip questions, and this is what it looks like when you skip partial questions. Okay, see, we skipped a partial question here. We had half of an answer there. See, but we didn't finish the whole thing. So that's what it looks like. Okay, so at the end of the problem, at the end of the test, if you missed any, just click on the drop-down menu and see which ones you missed, or you haven't, which ones you haven't finished. Go back to those and see if you can actually work them out. Okay. And then for like I told you before, if and let me take you back to my document camera real quick, and we're almost done. If you want to turn in your paperwork, it's going to look something like this. Okay, make sure you write the problem number, because if you don't, then I'm not going to know which problem you were working on, right? And you're not going to get any credit at all. I'm not even going to look at it. I'm not even going to bother. See what I'm saying? I mean, I'm a nice person, but not that nice. So make sure you include the problem number to the left there, inside the box or something like that. Work out the problem here to the left. If you need to work out some extra problems, do it to the right, away from your work. And then whenever you get to your answer, make sure you circle it. Circle your answer. Circle your answer. Okay? Circle your answer. And that's gonna speed things up for me. And that makes things much easier for me. Yeah, so that's if you want extra credits. Go ahead and scan your work, email it to me. I'll take care of the rest. Okay? I promise you that if you scan and email me your work, you will get extra credits. All right, so I think that's all I have now for this. Make sure you get that done before Sunday at 11 p.m. Yeah, you test. All right. All right. I'm done. Bye.